In today's lesson, we're going to graph and write equations of hyperbolas. So a hyperbola is basically what looks like two parabolas facing away from each other. Though that's not exactly what they are, but it looks like it. So the key features, or two key types of hyperbolas we'll deal with are a vertical and a horizontal, with a horizontal one on our left and a vertical on the right. And what makes them horizontal or vertical is a thing called the transverse axis. So if we look at the horizontal one, we have a vertex. We actually have a couple vertices, just like ellipses have. And between these vertices, we have what's known as a transverse axis. Okay? And there's only one axis on these hyperbolas, as opposed to two different types on ellipses. And these also have foci located inside the curves. So like here, I have one to the right of this vertex, located at C0, and one here located at negative C0. And note that the vertices are at A0, negative A0, and positive A0, respectively. So then, when we look at the other values, we don't have an axis running between these b values. I don't have a real name for them. I'll just call them our b values. We will need these in order to graph the hyperbolas, to create this box that's in between them. And so we have one here at b0, and then one here, I'm sorry, 0b, and then one at 0, negative b. Now our transverse, we have a thing called an asymptote. I'm sure you're familiar with those. We have two that run diagonally, one here through the corners of that box, and then here through the other vertices of our little box here. And those are going to be important things as well. Please note that the hyperbola equation is just like the ellipse equation, except it's got a minus sign instead of a plus sign. So here we have x squared over a squared minus y squared over b squared. So we have a minus instead of a plus. Thus, it gives us a new shape. So on the right side, we have the other hyperbola. This is a vertical one, so where the hyperbola is opening up and down versus opening left and right. So since this is a vertical one, opens up and down, the transverse axis we can also see runs vertically between the vertices. And as we expect, as we saw on the ellipse, the values here switch. So now my vertex here is 0a and 0, negative a, respectively. And then my b values are negative b0, b0, and then my foci are located here at 0c and 0, negative c. I want you to pay a particular note, though. Instead of the a and b switching, like on the ellipse, it's the x and the y that switch when you rotate it 180 degrees. So when you go from horizontal to vertical, or vice versa, it's the y and the x that change versus the a and b on here. So here's a summary of all this. So the equations, we have x squared over a squared minus y squared over b squared. This describes the horizontal one with the transverse axis. Now those asymptotes I talked about, these are lines that have a slope, and that slope is determined by b over a, again, plus or minus, so we have them running in opposite directions. We also have vertices. which we just went over, plus or minus a, 0. And then on the vertical one, we're going to have our asymptotes, and as you notice here, the y and the x are switched. The asymptotes on that one is going to be different. It's going to be a over b. So a on top, b on the bottom. And then it's 0 plus or minus a. Of particular note, the foci can be found. They're C units from the center of the transverse axis where it crosses on the origin, and it can be found by c squared equals a squared plus b squared, which looks remarkably like the Pythagorean theorem. So if you remember the Pythagorean theorem, you can remember the relationship between a, b, and c for the foci on hyperbolas. Okay, in this first example, we're going to graph x squared minus 4y squared equals 16. So the first thing I want to do is I want to rewrite this in standard form. So I'm going to set it equal to 1 by dividing 16 into everything. So I'll have x squared over 16 minus 4y squared divided by 16 equals, well, 16 divided by 16 is 1. I can simplify this further by simply reducing this to 1 over 4. So, or just y squared over 4. So, therefore, my by looking at this, I'm going to be asked which direction is this? Is this horizontal, opening up to the left and right, or vertical? And what I notice is that here it's x squared minus y squared. So the y squared is negative. Okay, so if we look at our formulas, this one's going to be the horizontal because it's x squared minus y squared in that order, or you can think of it as y squared being negative, either way. And so I'm interested, so I know that this is going to be in the form of x squared a squared minus y squared over b squared equals 1. So it doesn't matter because the a and b is always going to be in the same location when you're talking about hyperbolas. So my a in this case is going to be 4 and my b is going to be 2. So 4 squared and 2 squared, which is going to then identify my vertices and my b values, which I'll just call b val. I'll just abbreviate it like that. Because it's horizontal, the vertices are going to be on the x-axis. They make the transverse axis. So those are going to be the values plus or minus 4 and then 0. And then my b values are going to run vertically on the y-axis. So that's going to be 0 and then plus or minus 2. Okay, so I have my, I'm going to box those in because I'm going to need those. And now I need to identify my, let's go ahead and find the foci. And the foci can be found using that formula c squared equals a squared plus b squared. So in this case, it's going to be c squared is equal to 16 plus 4. So thus c squared is equal to 20. I'll take the square root of both sides. So it's going to be plus or minus 20. Square root of 20, and then c equals plus or minus, if we reduce 20, it's going to be 2 square root 5. Okay, so that's going to be my foci. Let me write that as points first. on the same axis as the vertices, so it's going to be plus or minus 2 square root 5 and 0. And then I'll box that in. The next thing I need to find are the asymptotes. And because this is a horizontal one, it's going to be y is equal to plus or minus b over ax, where b over a is going to give us our slopes, one positive, one negative. So our b value is 2 and then 4, so plus or minus 2 over 4x, which reduces to plus or minus 1/2 x, okay? And that's going to be our asymptotes, okay? And I should box that in. Okay, now I can, when graphing it, I'm going to plot all these points. I'll start off with the vertices. So we'll have one at positive 4 and negative 4. And the hyperbola is going to pass through those points. Those are the only 2 points it's going to pass through. The other points are going to be guiding points. And my b values, as I call them, be at 0, 2 and 0, negative 2. The foci are just going to be shy of 4.5. It's like 4.4 something. So one there and one there. Okay, and then what I could do is I can actually draw a box, a rectangle, if you will, that will connect the vertices with the b values. So it's going to be something kind of like this. Okay. And then I'm going to use my slope of 1/2, where I go up 1 over 2, you know how that goes, and I'm going to draw those lines. And these are going to be my asymptotes, and this is going to be kind of help guide my hyperbolas. Hyperbolas will not cross these asymptotes, like so. And they have a tendency to go through the vertices of this box. And then once we have that, we can just draw a graph that goes that just avoids the various dashed lines, the asymptotes, but goes through the vertices and around the foci. And you're just going to follow along them very closely, and it should look like this. So that would be our first hyperbola. Okay, in our second example, we're going to write the equation of a hyperbola, given some information. So I find it helpful if we could just draw a rough graph and plot some points to give us an idea of what type of hyperbola we're dealing with. So we have the vertices located at 0, -5, and 0, 5. So they're going to be on the y-axis. So here and here respectively. And the foci, of course, are going to be on the same axis. So because the vertices are going to be on the y-axis, this is going to be a vertical hyperbola that's going to be opening up and down respectively, something like that. So that tells us the equation we want to use is going to be a positive y squared, or it's going to be y squared over a squared minus x squared over b squared equals 1. Okay, so we know what our a values are, okay, it's going to be 5. So I've identified A, but that's given to us. But now we need to figure out what B is. So we're given the foci, so we can use the foci and the vertices and the little formula. So using that formula, c squared equals a squared plus b squared, I'll just substitute my c value, 8, and 8 squared will give us 64. And then we substitute a, which will give us 25, plus b squared. All we have to do is subtract 25 from either side, and that's going to give us b squared, which is 39. So in all reality, I don't need to know what b is, because for the equation I just need to know b squared. Thus, when I write my final equation, it's just going to be y squared over 25 minus x squared over 39 equals 1. And I would box that in, and that's going to be the equation that will go through those points. So that's how you graph and write equations of hyperbolas.